here is a typical financial maths exam question, but we are just going to focus in on one of the questions. So let me point out which one it is. So we are going to focus on the one, Zakele inherits 10,000 Rand. Wouldn't that be awesome? And invests it in an account for 8 years. It says here, if the interest rate for the first 4 years is 8.4% compounded half yearly, and then it rises to 9.2% per annum compounded monthly for the remainder of the investment. The question is, calculate how much interest he has accrued on his inheritance. Okay, now I want to ask, based on the last lesson, what is the very first thing that we do? And maybe someone can come online and tell me, or you can put it in the chat, but there are some new students here. What would your first step be? What would your first step be if you were wanting to start solving this question? Okay, so Sadiq and Morgan and Mesh, everyone has pointed out that drawing a timeline is very, very helpful. And I totally agree. And the reason it's helpful is that it organizes all this information into a structure. And Oyisa agrees. Okay, so we know we want to do a timeline. I want you, here's the beginning of my timeline. I want you to put the information that you think should go on the timeline. Now, if you're brand new, you may feel a bit confused about this, but for students who were in the last lesson, just try and put what you think is the key information on the timeline that you think I'm going to come along shortly and do. The most basic thing is we start with T0 for the beginning. And because the question is 8 years, we say T8 is the end of 8 years. So that's the basics to start with. But I want you to fill in the other bits of information. Morgan has been even more helpful. Look at that. Now, Morgan, why is T4 a good thing to add? What is so important about T4 that suddenly I have to have another point on my timeline? What? The first 4 years, okay. And I think the main reason is that it's the pink and the blue, right? The interest rate is a certain way for the first 4 years, and the interest rate is different for the next 4 years. So what I'm going to do is I'm going to use a different color, and I'm going to say the interest rate here is not just 8.4%. I have to compound it half yearly, which means divide by 2. So the first 4 years have a half yearly interest rate of that. Okay. Now, we also have a second period where I'm going to use blue just to keep the thing going. And it's 9.2% per annum compounded monthly. So that is going to be, there's the 9.2%, but it's compounded monthly, which means I need to divide by 12. So what this does is it takes these horrible words and puts them into symbols that our brain can more easily understand. Now, there is one thing I've left out, and that is how much money Zakele actually starts off with. And what I do is I put that amount below T0 because that is where the amount started with. So I know that it's 10,000 that we are starting with. Let's go to the question. I want to go and Keisha, let's unmute you. Keisha, what is your question?
Hi, sir.
Hey.
So for the first period, you said 0.084 over 2. Why is it over 2?
Okay, great question. So in financial maths, sometimes they say annually, sometimes they say semi-annually, or half yearly. Sometimes they say quarterly. Sometimes they say monthly. Sometimes they say weekly. Now, if your interest rate is given to you in a per annum way, that means that it's once a year. So 8.4% annually is just going to be that interest rate per year. But if they say semi-annually, they mean every half year. And to make this interest rate a half yearly or semi-annually interest rate, I need to divide it by 2. If I needed it to be quarterly, I would divide it by 4. If I needed it to be monthly, I would divide it by 12. If I needed it to be weekly, I think there are 52 weeks in a year. Or maybe I'm making that up, but whatever number of weeks there are. Okay, so that's the one thing. The other thing is that we need to think about what formula we're going to use to actually grow this 10,000. So this 10,000 is going to go on a journey, and it's going to grow at a certain interest rate and get there. And then after that, if we know what we're doing, it's going to grow some more. And then that's where it needs to get to. But we actually need to use a particular type of formula for this. And it's going to be the compound growth formula. So it's going to be the one that looks like that. So I want you to try and take the 10,000 and let it grow to the red X, and then grow it some more to get to the blue X, and try and get me what you think is the final answer that is sitting in the account. You can put your answer in the chat when you feel like you've got it. Now, the hard part is knowing what the number of time periods is. So the number of time periods, because it's 4 years, but we're going in half years, we just go 4 times 2, or 8. There's 8 half years in 4 normal years. So that needs to be that. And that would get, whatever I got at that point, that would be the red X. But to keep going, to get to the end of the 8 years, I have to then take this bit and pretend that this is the input for the next one. And now I need to know, what is the number going to be in the blue block before we get our final answer? I see some of you have got the final answer, which is not a problem. So you've got 4 more years, but now we're working in months. And the reason I know it's in months is I see this 12 here. And so this is going to have to be 48. So how much money have I got sitting in the account? Well, I can see in the chat that many students have done this, and you'll get 20,051.76. Now, that is how much money is sitting in the account after going through the journey of growing. But there's a catch with this one. If you look at the question, it says, calculate how much interest he has accrued on his inheritance. So he started out, his grandpa or granny gave him 10,000 Rand. In the bank account over here, you've got that much money left. But the question is, how much interest has been generated on his initial inheritance? I want to see if anyone can tell me how much interest has been generated. Now, there's a difference between how much money is sitting in the account and the amount of interest that has been generated on the initial principal. Does anybody want to come online and tell me how that works? What's the difference between, like, the interest is the difference between the original and what you end up with. So what's that going to be? Would anybody like to give us a comment about what I'm talking about? Like, why is this question different? When it says calculate how much interest he has accrued on his inheritance. Why is this a little bit different? In the past, we'd normally say how much money is sitting in the account, but the question is slightly different here. Okay, so I can see people have got it. So all you need to do is take how much, yes, Morgan, difference equals minus. So what you're going to have is you're going to say, look, I've got this much sitting in my account, 0.76. I started out with 10,000. And so the amount of interest that has been generated by sitting in the bank account is going to be that much. Okay. Give me a thumbs up if you followed that. Give me a thumbs down if you're feeling unsure about that. Okay. Now, you've done okay with the first financial maths question today, but what I want to do is, this is such a lovely old exam financial maths question that I want to do the one that isn't even isn't a timeline question. So for those who are still struggling with timelines, don't worry, I'm going to do another one after this. But before we get there, can you have a go at this one over here, 4.3? So this one is not a timeline question. It's just a good old-fashioned financial maths question from earlier in the series. And just see, maybe we can do it together. So 4.3, Sipho invests 15,000 Rand in a bank account. After 5 years, he withdraws, or he has access to, 28,000. It says calculate the interest rate rounded to 2 decimal places per annum if it was compounded half yearly. Actually, you know what, guys? I've changed my mind. Let me rather stay with, I'll come back to that one. Let's do one more like this. Sorry, I shouldn't have mixed you up like that. Let me rather go and do this. So let's do this one. I want you to try and do this question. Try and do this one by yourself. For those students who are feeling unsure, I want you to ask a question in the chat about where to start. But for those who are feeling comfortable, see what you can do with this question. How did we get the 48 in the previous one? Okay, good question, Rizika. Let's have a look. We'll bring it back while. So, Rizika, the question that you're asking about is this 12 maybe, and it's that 12. And you're saying, how is it that this bit over here is 48? Now, if you look at the scale, T4 to T8, the difference is 4 years. So there's 4 years in time that needs to be traveled. But I don't want to know what 4 years is in years. I want to know what 4 years is in months. And the reason is because in this question, I need a monthly interest rate from year 4 to year 8. And so I need my interest rate per month to match the time periods in months. And so what we say is, how many months are there in 4 years? There are 48 months, or 4 times 12. Okay, so I hope, did that help, Rizika? See if you can try out that idea in this next one. Okay. So T0, T7, T4. Pleasure. And you see, that's why asking questions in class is so important, because it doesn't just help you, it helps other people in the class too. And so that's where you must never be afraid to ask a question, because there's almost definitely someone else who wants you to ask it. Okay, so what do we have here? Compounded quarterly. So we divide by 4 because it's per quarter here. I know that it's a 7.5 there. And then for the next one, divided by 12. And the 80,000 is what is sitting at the bottom, and it has to grow through this time period and get there. And then it has to grow, let me use green rather. It has to grow through that time period and get there. And we start with 80,000. And then the question is, what is going to go there and there? And then after we've done that, the question is, what is going to go here and here? So I'll give you some more time. I think the red block is probably the trickiest one. I think we all know that this part is going to be whatever the interest rate is up here. And then this part over here is going to be whatever the interest rate is up here. But now the block. So this is going back to the question. What number is going to go here? Well, this is in 4s. It's in quarters. But there's 4 years, and 4 years in 4 quarters. Well, that has to be 16. There's 16 quarters in those 4 years there. And then here it's per month, but remember there's 3 years. Now 3 years in months is going to be 3 times 12 or 36. And so what does that get up to as my total? I want a lot of students to put the answer and let's see if we all agree. So 1 for 1, 768.60. Okay. So really with this thing, if we go over this question, setting up the timeline is really, really important. And then attaching the interest bits to the right place. How did I get 60 and 36? Okay, let's go back. So first of all, if we look at this bit here, this is 4 years from T0 to T4. But the problem is, I don't want this time period in 4 years. I want to know how many quarters are there in these 4 years. Now there's 4 quarters. There's like saying how many seasons are there? So there's 4 seasons in 1 year. So, but there's 4 years. So there's 4, 4, 4, 4. Then I get 16 because it's 4 times 4. Now, if I go to the next bit, this is 3 years, but I don't want to know about quarters anymore. I want to know about months. How many months are there in 3 years? 12 plus 12 plus 12 is 36. And so the reason you'll see that the 36 months matches the fact that the interest rate is in months in that question. Okay. So I hope that helps you understand a little bit. It's almost like you have to translate the time into the right quantity of time to help you. Okay, now what we're going to do is we're going to do a different type of, well, similar question, but slightly different. I want you to read this question by yourself, and then I want you to tell me what is different about this question compared to the last question. What is different about this question compared to the last question?
Teresa.
Yes, how's it going? What do you think is different?
Oh no, so I just wanted to ask a totally different question.
Okay, no, that's fine. Go for it.
It's been stuck on my mind. Is there any other way besides timelines that we can solve such questions?
Okay. What you could do is, well, no, you do need a timeline because you need to understand the visual representation of this. I have seen some teachers do, like, they'll do this bit, get an amount, and then go and do the next bit, which is essentially what we're doing, but I've seen them do it like completely separately. Like they get an A value and then they feed that A value into the next part of the calculation. But from my experience in the class, I would say just keep practicing with this way, because once you get it, it's so adaptable and so efficient. But there isn't really, you always have to draw a timeline because it's really difficult to keep track of things otherwise.
Okay, thank you very much, sir.
No problem. Okay, there are deposits. Okay, so I'm looking in the chat and I'm seeing that it says people have realized there's 150,000, which is all good. There are different interest rates, but there's another deposit that gets made at some point. So at some point, more money is coming into the bank account. And then at another point, there's another 2,000 that comes on the scene. Now, this is interesting because it means that the thing that is at the very beginning, it gets to grow for a long time, right? It gets to grow for the whole life of this question. The 8,000 that comes later on the scene, it only grows for a little bit of time, and maybe the 2,000 grows for the least amount of time. And so we need a way of incorporating this into our timeline. But can I suggest, Mbali and Zanele have suggested that the formula for, okay, I'll mention that in a moment. That's with regard to time. I absolutely can put that in. Thanks for that tip. So I want to suggest that this first part, before I worry about the deposits, is I'm going to worry about my timeline like normal. So T0 and T6 come from the fact that this goes on for 6 years. Now, at some point, after 4 years, there's a change in the interest rate. So I'm going to do exactly what I've been doing every question so far. I'm going to put the interest rate in, and the interest rate here is 0.12 divided by 2, and the interest rate here is 0.085 divided by 12. Give me a thumbs up if you follow that first bit. Okay, now here comes the interesting stuff. I want to suggest that the 150,000 is the OG amount, right? Original amount. It gets to grow for 6 years. But that is not the only amount that gets to grow. What about this 8,000? How long does the 8,000 get to grow for? How long does the 8,000 get to grow for? So it only comes on the scene after 1 year. So what I'm going to do is I'm going to add T1, because that's when the 8,000 arrives on the scene. Oh, you're quite right. Sorry, you've spotted it, Morgan. Well done. Sorry, I made a mistake in my time thing. This should actually be over 1 because it says per compounded yearly. It doesn't say compounded monthly. It says compounded yearly, and compounded yearly would be over 1. So thank you so much for spotting that. Now, back to the deposit of 8,000. It only comes on the scene after 1 year, which means that it actually gets to grow for 5 years. Now, what I do is instead of writing the 150,000 and then writing the 8,000 below it, that's really confusing. I'm going to write the 8,000 in a separate row, but I'm going to write it in line with the T1, because then I know it only gets to grow for 5 more years. And that helps keep my brain organized. Now, am I done with this question? No. I need to figure out where the 2,000 is going to go. So a deposit, and then another deposit is made 5 years after the initial investment. So if this is only made in year 5, I'm going to have another point on my timeline. And below that, in a separate row, I'm going to put a plus 2000. Now that shows me visually that this only has one more year to grow. So the first thing I want to ask you is, do you understand why the 150,000 is in line with T0, 8,000 is in line with T1, and 2,000 is in line with T5? Give me a thumbs up if you understand why they're in different places. Okay. Now, if you have multiple deposits, it's really important that your brain doesn't get overwhelmed. So what happened here was the 150,000, it was at the beginning, T0. It gets to grow for the whole timeline. The 8,000 is only deposited after the first year, and that's why it's in line with T1. And the 2,000, it's deposited after 5 years, and that's why it's in line with year 5. But obviously, all three of these values have to get interest on them, which is what I'm going to come back to after the break. So we don't have to know it all now. We're going to take a break, but I just wanted to show you how the first part of this question was the black timeline, just like before, and then one small change where you have different amounts coming in at different times. But let's take a break because we've been working hard and we need our bodies to be taken care of. So I want you to make sure your cameras are on and on your feet, and let us feel like human beings and get on. Okay. Are we on our feet, people? Let's see you shining brightly. Okay, so I'm up and I'm going to stretch. And let's take a nice deep breath. Oh, it feels fantastic. Let's take another deep breath. And one more. Okay, it's nice. Shake out the arms, shake out the legs. Let's roll the shoulders back a little bit. Let's roll them forward. Okay, let us do some small circles and gradually moving into bigger circles. And then we're going to reverse the direction with our big circles. And we're going to go back to small circles. Okay, then let's do some triceps. You should feel the shoulder stretching. And then let's switch to the other side. Okay. And then let's do some rotation. So we're just going to start by turning like this, a little bit. And then as our bodies unwind and relax, we will do this. You should feel like you're turning further and further. Oh, look at me. I'm going to turn the whole way around one of these days. Okay. Then let us do some heart rate. And it's been a while since we've done jumping jacks. So we're going to do jumping jacks. Make sure the space around you is clear so you don't whack anything or anyone. And we're going to do 20. So we start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa, lost my thing. 15, 16, 18, 19, and 20. Look at us making it happen. Okay, well done, everyone. I hope that you are feeling alert and alive and awake. Let us quickly do a Maths 24 question just to keep our times tables fresh in our head. can you make 24 from either of these two cards? Yeah, I did actually love the participation today. It was awesome. Who feels like they can solve the Maths 24 today? So, Chigavatso and Mbali and Zineda on the money. So there's a couple of ways: 6 plus 6 times 2 times 1, or 6 minus 2 times 6 times 1. Both of those will give you 24. So well done there. Can anyone do the blue one? So that's a 6, an 8, a 7, and a 2. I think blue one is a bit trickier. Even I'm having a moment here. 13. Okay, or maybe we can save that for another time, because it isn't immediately obviously coming to me. 9 times 6, 48. Okay. You can take a screenshot if you want to struggle with that one, but I'm also, that's a toughie. 8 minus 6, 2. No. Okay. Sometimes you just, oh wait, has Annie got it? 8 plus 6 is 14. Almost, Annie, almost. But you got to 23. You got to 23. So you're close. Okay, let's get back to this, because we'll do Maths 24 again, and I will go from there. Okay, I see. Let me quickly find you here. Where have you gone? Okay, back to this. All right. So if we're going to grow all three of these amounts, the formula that we're going to use is still going to be the compound growth formula. But what we're going to do is we're going to start with the 150,000, and the 150,000 has to grow through the blue part first of all. So the blue part is going to be this. Now, what is the number that's going to go here? Now,
hi, sir.
Hello.
I'm really sorry to take you back, but the previous question before this one, I just can't get 141, the answer that you got before.
Okay. Let me come back to that later in the lesson, or let's just check that we match this one. It could be a calculator issue, and I'll go through the calculator technique very carefully on this one. Okay. So let's just check if we get this, because it might be your calculator being in the wrong setting or something. Okay. So let's compare on this one, very detailed comparison. So if you look at this one, we have 4 years to travel, but because we're going in half years, all we need to do is take the 4 years that you've got. In fact, this is maybe I should have been saying this earlier on. You've got 4 years, so you write 4, and you times by the number that you're dividing the interesting by. So you get 8. Now, following that same logic, it still has to grow for 2 more years after that. Now, how much does it have to grow by? Well, it's going to be that over 1. And if we think about that here, how much time is there? Well, there's 2 years, and we times by the number that's below there, so that's 1. So essentially it becomes 2. And so if I had to just get that amount, let me do this on my calculator, 150,000 times 1 plus 0.12 over 2 to the power of 8. And then what I do is I go equals, and then I go times by 1 plus 0.085 over 1, close bracket, to the power of 2. Now, if I stopped at that point, now it's not correct to stop at that point, but if I stopped at that point, I would get 281,447.6699. Just give me a thumbs up if that's what you would get too, just so we can check that our calculators are all working nicely. Why did I get 2 times 1? The reason I said 2 times 1, Sadiq, was just because there were 2 years. I'm trying to show the relationship between the number of years and this number over here. So because there was 2 years, and because this was in 1 yearly increments, it was just me trying to show you, basically before I would have written just 2, or I would have written just 8. Okay, now the problem is we don't just have this amount, although it's not wrong to write it down, we also have to deal with the 8,000. Now, I want to suggest the 8,000 has to grow at the blue rate until here, and then it has to grow at the green rate to get here. So what I'm going to say is I'm going to set up 2 spaces for everyone to think about, and I want to know what is going to be the interest rate that I put in the blue block. What is the interest rate that the 8,000 has to grow by in the blue block? Now remember, this is the 8,000 that is, it's starting out life over here. Okay, it's going to be 0.12 divided by 2. Okay, we've got that. Now, what is the amount of time? What is the thing over here going to be? Now, remember, I've got to ask myself, what is the interest rate? And it's a half-yearly interest rate. And what I want to say is there's 3 years left. There's 3 years left going from T1 to T4. So I'm going to write a 3, but the 3 is not correct because the 3 needs to be broken up into half years. And the way to do that is just to times it by the number that I'm dividing by here. So 3 times 2, which would give me 6. Now, I think for some of you who are struggling to see it in the timeline, just knowing that you count the years and you times by the number below. Oh, fantastic, Tando. I'm so glad that you figured it out. That's even better when you figure it out yourself, because then you know, actually, I've got this. Now, when I get, so this part over here is going to be 6. This next part is going to be 0.085 over 1. What is going to be in the green part here? How long is this going to grow for? It's just going to be 2. You can say 2 times 1 if you like, but it's essentially just 2. Yeah. Now, we're actually not done, ladies and gentlemen. We're actually not done because there is a 2,000 that is saying, I feel left out. I want some attention too. How long does the 2,000 get to grow for? Just 1 year. Just 1 year. What interest rate does it grow at? Well, you can see from your, I'm running out of space here, so let me make this thing smaller. So what we have, and this is just going to be, you can say like 1 times 1 if you like, or just 1. Now, you've now tackled a seriously difficult question, and all you had to do was keep track of your timeline and then split this into 3 pieces. Now, what I would do when adding this up with your calculator is there's real potential to make a silly error, But all you need to do, I'll give you the answer in a moment, but I want you to try and do it for yourself first, is when you type this in your calculator, you just keep pressing equals. So I would start with this and then hit equals. And then I would times by the green thing and hit equals. Then you've got an answer in your calculator. And then you go plus, and then you go 8,000 times this equals, oh wait, let's have plus 8,000 times that. Oh, we need to be careful. Okay, we need to be careful with that one. So let's just make sure we get that answer plus this time. Okay, be careful on that one. Let's see what we get as our final answer. Put that into your calculators and see what you get. You should be getting that over there. Yeah. Clan Apple, let's unmute you. Yes.
Afternoon, sir.
How's it going?
It's going great. Can I ask? You see,
Yeah.
there, ne?
Yeah.
Why is each amount receiving 2 brackets? And when do we apply what you just did?
Okay, such a good question. And I think a lot of students are thinking about this. So Klanapo, if you look at my timeline, can you see there's a blue interest rate and a green interest rate?
Yes.
Can you see that? Okay, now here's the thing. The 5,000 has to travel, sorry, the 150,000 travels through the blue interest rate, and then it switches to a different interest rate. And that's why there's 2 brackets, because the 2 brackets are handling the 2 different interest rates. Does that make sense? Now, if
Not
you look
yet.
at the, not really, no, okay. Okay, I'll show you why, okay.
Yes.
If you look at the 2,000, can you see the 2,000 doesn't line up with any of the blue interest rate? Can you see this 2,000 here?
Yes.
Now, can you see it only has 1 bracket over here?
Yes.
You see it's only got the green one. It doesn't have the blue one. Why does it not have the blue one as well?
Doesn't pass by the other interest
it doesn't
rate.
pass through the blue. It doesn't it's not on the scene when the interest rate is blue. So that's why if you go back earlier and you have to go through the blue and the green, you need that in your calculation.
Oh, okay. Thank you.
Does that make sense? Kind of. It's hard. I'm not going to lie to you. It's hard, but I mean, if you go back and watch this again too, I think it will start to make sense.
Thank you.
Pleasure. Okay. So why don't we do another one of these questions to finish off with? Can you do 7.3 for me? Have we done 7.3 before? I don't think so. Let me know in the chat if we've done it before. But if not, let's do 7.3. Oh, Bianca, I can go up. Yep, I can. I can absolutely go up. Don't worry. Let's get the whole thing in focus so you get the whole experience, the whole. That's quite a question, hey? Maybe I should even zoom in so that you get the original question too. How about that? It looks like a mad scientist was on the scene, hey? Okay. Cool. Let's do 7.3. See if you can do it by yourself and then ask questions. You can either raise your hand to ask an audio question, or you can put it in the chat. And I'll see if you can do 7.3 by yourself. So it looks to me like there is 2 different interest rates. And because there are the green and the blue interest rates, there should be 2 brackets to handle the 2 different interest rates. Okay, so that's the one thing. The other thing is now figuring out, okay, cool, I know what the interest rate is, but how do I know what the time period is? Because that's the tricky bit. So we know that this is going to be, and what I've been saying now, and this was suggested during the lesson today, is that if that's 2 years, you can write 2, and then all you do is times by the number that's being it's dividing by. So that's going to be 24 for that one. And then here, I've got 2 years to 6 years. That's 4 years, but I times it by the number below here, which is 2, which is 8. And then the question is, what do I get for my final answer? How much is the 30,000 grown to? It should have grown to 58,017.51. And for bonus points, how much interest has accumulated on the original amount? How much interest has accumulated? What's the difference between the final amount and interest? So the interest is the difference between the original amount and the final amount and the original amount. So it would be 58,017.51. And what did we start life out with? It was 20. Oh, guys, did I just make? Oh, no, it was 30,000. Almost made something up there. So we should end up with 28,017.51. That's how much interest was earned on the original 30,000.